welcome to our DevOps meetup for today. The theme of today, the topic we talk about is what is GitOps and why should you use it? And we have our speaker tonight. This is Christian Jakob, myself, here. As mentioned, this screen will be recorded. So if you prefer not, the session will be recorded. If you prefer not to be on this recording, then just make sure that you do not ask any questions or switch off your video. We will upload the video later in the Vimeo channel, so that if at a later point in time you would like to see this talk again, you can see that in Vimeo. My name is Martin Thalmann. I'm the moderator tonight. I'm host of this meetup together with Romano Roth, and I'm also co-organizer of DevOps Days in Zurich, the conference. So the meetup and the DevOps Days will be organized by the same people. And what we do tonight, I give a very quick intro. What happens, I will say a couple of words, short welcome message, and then the most important part, of course, is the talk itself. Don't be too accurate about the timing. Might be that it takes a couple of minutes longer as well. And especially we will have enough time for further questions and discussions, so to really go into the details there. I changed the settings. We are not that many people tonight, so I changed the setting. You can all unmute yourself. I'm not that strict with that. Oh, I guess a couple of people are waiting. Just a second, I stopped the recording and I need to, so sorry about that. So I changed the setting that you all should be able to unmute yourself. Please just use that if you want to ask a question. Would be nice if you do not, misuse that. And I guess, Christian, is it okay for you if we interrupt you for questions, if there's anything?
This is much appreciated. It's better than just talking to a screen, which is silent. Okay,
so we make it really really interactive then. Please disable your microphone when you do not ask a question, so we do not have any disturbing background noises. And then the other thing I mentioned already, DevOps Days. DevOps Days are a two-day conference all about DevOps. Is 7th and 8th of September. Will take place in Winterthur. We are very happy that we can host that as a physical event, and get your ticket now. We have a limited number of tickets, so it would be nice to meet you there, to meet you in DevOps Days. And Christian will be one of our speakers, so really happy to have him here. So if you want to meet him in person, then DevOps Days in Zurich would be the right place to go. The last thing I want to talk from my side is about the meetup. This meetup, if you are have any idea, if you want to give a talk in such a meetup, then please reach out to me or to us, so we can. We are always looking for interesting speakers, for proposal of topics. Probably we can go back to physical events soon as well, and then of course sponsoring of the beers or the location would be very interesting and much appreciated as well. And now I go back, I stop sharing my screen again to let everybody else enter the meetup. Now I'm really happy to introduce you Christian. Christian is, he founded a startup in the IAM business, Chaos startup. Chaos it's called. It's really interesting. He's a DevOps enthusiast, and besides having his own startup, he's also consulting in the DevOps area. And what he talks about today is what is GitOps and why should we use it? Christian, we really look forward to your talk, and the stage is yours. Thanks a lot.
Thank you for the introduction, Martin. As you said, me and my colleagues, we're 11 people now. We founded Chaos to enter the market for IAM business in Switzerland. And me personally looking for all the former known as ops business and now DevOps business. So we automate things. We are pretty strong in the Kubernetes business. We like to be lazy. We like to build microservices. And GitOps was our weapon of choice to make our software happen from a ops point of view. Let me try to share my screen and start the speech. Of course, I prepared slides. So, first of all, as mentioned before, if you have any question, I would really like you to interrupt me. I'm fine with that. If you have detailed questions or any hints, just let me know. I'm fine with that. It's better to just sitting in an empty room and talking to a monitor. Whatever. Let's get started. What is GitOps and what can it do for you? Well, and how do I get the presentation to the next slide? A little bit of history. How we did things in the past. I mean, basically, what devs and ops were in the past was developers code their software, have some kind of a package, hopefully in some kind of a package store as Artifactory, whatever, give their package to an ops person, and he would install it onto his system. After a while, things get that complicated that the need for documentation and the need for some kind of a ticket system to have specific tasks. So people started documenting, and ops person did the same, but with paper. After the rise of pipelines and the disadvantage of designated continuous integration and continuous delivery servers at all, we switched to a CI/CD ops kind of thing where pipelines do things, have their documentation, and try to install a piece of software on the target system. Well, nowadays, we have the new competitors, which is, of course, DevOps. You know what DevOps is? That's the reason we're here. Meaning we have cross-functional teams, meaning the dev people and the ops people don't just look at their business, but their main goal is to have a functional system and a functional piece of software to satisfy their customers. And of course, on top of that, we have GitOps. So what is it? After searching in the internet, I read Reconciler. What is GitOps? GitOps is about reconcilers and operators to fully automate infrastructure as code, or probably a specific operating model just for Kubernetes, or probably a specific tool to provision software to a Kubernetes cluster, or probably a fully automated way to deploy containers, or just magic for container nodes. Most of the things I read was just container and or Kubernetes focused. I had a different thought about it, and I just wanted to say this just reflects my personal point of view and the experience we had with the last 2 years where we use GitOps as our main delivery method, I should say. So in my opinion, GitOps is a technical interpretation of DevOps. Let's look, we have still different mindsets between different, let's call it, departments. A developer cares about features, code, build, hopefully test as well, his artifacts, his story points, and his sprint. The ops on the other side just cares about sleeping well at night, the service level agreement, his config management, the environment deployments, security, monitoring, yada, yada. And if an application would have a mindset and dependencies, he would probably care about his customers, subsystems, the data it needs to run, the logic that it has to run, the performance it has, and of course the infrastructure it runs at. So basically the streamline or the delivery method is always the same. Dev delivers, hands something over to an ops person enriches an environment through config management, secret, whatever is needed, some kind of applications to deliver the application. Hopefully there's kind of a feedback cycle and testing that gives devs test data and some hints out of the running application. But in general, this is the way it always used to be, and probably in most companies the way it is. So the basic idea of GitOps is create a repository just for your target environment. With environment, I mean cluster. It could be a Kubernetes cluster, it could be just a box, it could be a virtual machine, whatever you want to call it, your environment or any environment. And the main goal is you declare how your application should look like at the target system. Just like a piece of music. You declare how it should sound like, how it should be played, and you want to be as precise as possible to store every information you need to reproduce your environment and or application. Think of it, you have a completely empty virtual machine or a completely empty Kubernetes cluster. On top of that, you want to declare every little piece to be able to describe your application as precise as possible and reproduce it at any time as every information is declared already. So basically, think an application with a core. An application consists of probably UI, backend, database. For the database, you can take any piece of stateful data, S3 storage, NFS, share, file system, whatever. So you have logic, some kind of front end, some kind of backend. And this is just the basic description of your application. It doesn't know where it has to run. It's just which components do I need to have a functional application. This could be the dev's kind of view when he does his tests at his local box. In addition to that, you have different flavors of an application because you want to have a specific environment like development, test, or production. And of course, these environments will have different secrets, different configuration, different data, probably different versions, hopefully. And of course, different demands as production needs to be backed, as dev might not, and so on. In addition to that, depending on where you want to run your software, you might need helpers. You might need certificates, reverse proxies, API gateways, monitoring facilities. You want to have a look at the logs, whatever. If you use a hyperscaler, most of them will bring you their own suite, like AWS, Google, Azure does. But if you choose to use their tools only, you have your vendor lock. So it's up to you if you want to use their tools or if you want to have your own tools. Probably you have already established tools in your company, so therefore the need to use them as well is there. So what we have an ops repository. We defined our application, probably multiple flavors of it, and if needed, some helpers. So we still need some kind of magic to get us to our environment, let's say infrastructure. If it's just to be precise, it doesn't have to be Kubernetes, it could be anything. That's what we got. Within GitOps, but we want something different. We want the magic within the environment, have a repetitive look at an ops repository, have a look at the sheet, speaking in music again, what has been described, and apply what has been described to the environment. That shifts the complete deployment point of view, as you're not delivering something, but just telling your target system, have a look there. There's the description. Take whatever you want, what you think is right for you. Of course, you need some kind of logic, some kind of magic, because a simple description doesn't make things happen. There are multiple techniques within GitOps you might use. One is a reconciler. Basically, reconciler, as written, is a piece of software that looks for changes in a Git repository, let's say every minute, every 2 minutes, and applies these changes. Simple as that. As an example, just install a piece of software. As said, that's the way it does it. There's your description. Yep. Was that kind of a question? I was happy.
I guess this was more an audio flicker than a real question.
Sorry.
Yeah.
If so, just interrupt. Anyway, so you need to introduce a reconciler at your target system as the first piece of software without before installing anything else, and tell it, you know what, there's your ops repository, there is a specific path within your repository, check it out and install what's there. Hopefully, if you configure it right, you should have an application. Beside that, you might have the need for an operator, because reconcilers are pretty good in reproducing the description, but they don't know anything about your application. They just know there's a Git repository, there's a path I have to watch, and they apply things. So you need to have someone who knows a single application pretty well and reacts on events on that application. Best example is backup of a database or anything, backup of your production database before you apply any new version for your specific application. So the basic idea is the same. You check in repository, you apply a certain stage to your application, but in addition to that, you check events, you check a status. And you can do the full cycle anyway. You can go that far to have a cluster checked and the changes being made by a human reverse checked into the ops repository. It depends on how far you want to go. We already tested that approach. For some applications, it works pretty well. For others, it is pain in the ass and a nightmare. Depends on your needs. So which one is right? The reconciler is pretty cool if you handle a lot of applications and you want to have them installed reliable. There are a lot of on the market. For Kubernetes, the old kids on the block are ArgoCD and weaveworks, which merged a couple of years ago, but still have two different code bases. And in my opinion, even if the logic is used differently, Ansible and Terraform would have the same flavor. I would just not use them as a push platform, but I would use them to pull information out of a repository. The operator on the other side is just good for a single piece of application. There are plenty out there for databases. One of the best is the Prometheus operator, which completely automates your monitoring approach, or probably your own operator if you have specific needs for your application. So what is the main benefit in a nutshell? Well, you stop fiddling knobs, tweaking things, stepping on it and pushing something. Instead, you tell someone to pull something, but you need to be very precise in what you ask for, because you want to declare your application as precise as possible, as the pull is just a boxer machine, and you have to be very careful about that. So GitOps in a nutshell, it is a point of collaboration, because as you declare everything within a single ops repository, your ops guy will take care about the status of its application within the repository. And your dev guy, which, might be the same person as well, might take care about the image versions of your application. So both collaborate through Git commits in a Git repository. Each commit, each status is then being interpreted by a reconciler or operator, depending on your needs, and then reflects in an application on the target system. What does that mean? Well, you can handle changes at your infrastructure, as you know, within your development process. Basically, you can do pull requests, you can do rollbacks, besides stateful data, which is always painful. You can historically track all of your changes you made to a certain environment, and you know exactly which software is at which environment, as there is no human or documented magic that needs to be added to make the software happening. Of course, it is as transparent as possible, as every information is needed in a certain Git repository. And yeah, it scales if needed, because who says you just can't point a single cluster into a single repository? We did live migrations from one cluster and one provider to the other to the same repository, and it worked out pretty fine.
Christian, we have a question in the chat, and Flavio is asking, how would these patterns apply to a serverless architecture?
That is a pretty good question. I haven't thought about that, and I have no idea, speaking honest. A serverless, I mean, basically, if you have code as application, there is no infrastructure piece where you would have your reconciler running at. I mean, you could have a centralized reconciler dealing with, let's say, your AWS calls or your Google calls to get your software up and running, but that would not be the same as you have a central component. And from our interpretation of GitOps, you want to avoid that central component. So you need to have some kind of compute to make this reconciliation happening, but at the target system. With serverless, never tried. Contact me, let's give it a go.
And one suggestion by Adam was, would it be possible to run the reconciler in Lambda?
Weapon of choice. You can use any language or any technique you wanted to use, because you have to understand it by the end of the day. Because you have to maintain your reconciler. It's not just having that famous magic. You need to have a look at it. You need to have to take care about it. If you, as an example, if you do one reconciler the same, when you write it yourself and it deals about the dev, the test, and your production environment, you need to test the reconciler itself. If you want to deploy it and you find your error or your mistakes within the 3 environments immediately, you're having a bad time. Therefore, you need to be very careful that you understand what your reconciler is doing or what's supposed to do. Is that okay?
Seems to be fine. Otherwise, I guess people will write again or speak up by themselves.
More questions?
I think this is actually quite an interesting point, because I think that the polling approach would actually not work well with a serverless architecture, but I never thought about that. I think it actually, because it could actually cause more problems than it actually solves. But maybe I'm wrong.
I never tried it, speaking honest. The only thing I would suggest is not having a centralized system to have the reconciler, because that would break the pattern completely. And in my opinion, as you said, would give more problems than solutions. Okay.
Thank you.
You're welcome. Any question is welcome. With advantages, of course, there are challenges. I mean, it is 100% transparent, as every information is within a Git repository. Not every company culture, not every person is fine with giving their big knowledge into a small little Git repository. This is a thing you need to address from a people culture point of view. There's no solution or one size fits all solution. People have to be aware and willing, because once you break that 100% transparency pattern, you're in the same business, because it runs 90.9% automatically. Beside that secret, which is only available for ticket for Mr. XYZ, that doesn't work. Same thing, collaboration changes. People will not SSH to a target box or pull a trigger on a pipeline or do things like that. They collaborate through commits in a designated Git repository. That needs time to get into the people's head. It's just, you need to get used to it. That really takes time. And as we have the advantages of Git being the single point of truth, it is the single point of failure as well. If you have 100 clusters and you have just a single Git repository, probably at one of the clusters, breaking pattern, you're having a bad time. So you really need to make sure that your Git is up and running. Complexity might increase, complexity will increase, because once you start having the favor of reconcilers, which install dozens of applications, you want more. Therefore, you will look into operator territory and it will get complex, definitely it will. Depending on your setup, I mean, it's pretty easy nowadays having reconcilers up and running in Kubernetes, but if you're in traditional VM world, the initial effort might be a bit higher. And as said before, if you decide to use reconcilers and operators, of course, they need to be maintained, they need to be tested, and they need to be updated, and that in a safe environment. Otherwise, you're in hell. And as a result of the declarative approach, secrets management and stateful data need to be handled descriptive as well. So you really need to handle these and get rid of the old-fashioned flavors, hard-coded secrets. You know, all the dirty little secrets you might have in your code. As being Kubernetes nerds, of course, make your life easier. Use orchestration. Try Kubernetes. If you never heard of it, try it. It's worth your time. For a simple reason. Containers in general force separation. And the ideal world, all container deliver you is logic. And you need to enrich them with configurations, and you need to enrich them with secrets and or with data. The good thing is you can use the same container with multiple configurations just within seconds. At your local environment, let's say your software developer is testing the software in exactly the same manner as you do at your production environment. This is a huge advantage. Of course, there are trade-offs sometimes in terms of complexity, but it's really worth the effort. We even run our pipelines within Docker. And it's the same pipeline that runs at a dev box. It's not really linked to GitHub, to GitLab, to Bamboo, to Jenkins. It's a container. You can move it anywhere. It's pretty comfortable. Containers don't lie. If you do it like that, there is no works on my local machine because it's always the same clean build, always the same behavior. They don't lie and they're pretty honest. On top of that, with Kubernetes, and that even abstracts the whole mechanisms more, and it orchestrates multiple functions automatically. Your load balancers, your certificates, your secrets, your stateful data, your whatever. If you're used to Kubernetes, you know what I'm talking about. In addition to that, it takes care of scaling. It takes care of your compute power, and it takes care of the separation of concern. You can really fully separate your environments and be sure that no one messes up your production environment if you do it right. One of the biggest advantages for GitOps with the Kubernetes world is it's being configured with YAML, which is declarative. Therefore, it's pretty easy to declare an application and reconcile it. And yeah, as said, it eases the separation between applications even more. Due to pods, services, service meshes. I mean, there are so many tools you might use with the Kubernetes cluster. It really is production grade right now. In order to be able to do that, you need to separate your essentials. So you need to do your shit. You need to separate logic from configuration, from secrets, and from stateful data. And it's not about sometimes you need to do it 100% and 100% precise, because you need to define your configuration per environment, your secrets per environment. And if you're dealing with stateful data, as most of you will do, you need to take care that your latest test database backup will end up in the test environment when you try to run your integration tests, and that your latest production backup will be taken before production will be deployed. So you need to really address that issue, accept it, and take care of it. Of course, you can build your own operator, which we did 2 years ago. And the only advice I can give you, beside which language, use the language you're comfortable with. I wouldn't choose a 500 megabyte memory consuming Java monolith to install a Apache, but keep it reasonable in terms of the consumption of the operator itself and the complexity, and it will increase over time anyway. And the strong advice, do not create your own operator monster. You don't want to have a monster that takes care of a monster, because you need to maintain it. And this gets with every new demand and every new functionality, and I know developers like features, every new feature needs to be maintained. And if you have your monster to control a monster, you didn't win anything. You will spend more time checking and deploying and whatever, handling the operator than the actual application. So basically, what is GitOps? Git as single source of truth. Everything being in a ops repository is the thing that's being reflected to reconcilers or operators on your target system. Developers as well as ops people collaborate through a single repository, always. There is no changing something on the box, changing something on the environment. Every information is the right word, that needs to be reflected on the target system. A firewall change, a needed Apache, a needed Nginx, whatever needs to be declared in this repository. And there is no hidden information beside that. So how do we collaborate? We change the pull the other way around, the push to a pull approach. We don't push things, we don't install things. We install a reconciler and tell a target system to pull its things, or many systems out of the same repository. We declare the status of a target environment instead of deploying and following boring installation steps, repetitive. We automate the process, as being said, through reconcilers or operators. And by the end of the day, hopefully, we will always have the same results. That is my PowerPoint. And I can follow that up with a bit of a practical demo, if you'd like me to do, just to give you a flavor how this looks like.
That would be nice. Yeah, thanks a lot.
Let's have a look if that works. That works almost. And if there was a browser, I'm pretty sure, but I guess this is due to the screen share. That looks much better. Okay. Just as a small demonstration, what did I do? This morning I created 2 Kubernetes clusters at Google. One completely installed, the other completely empty, as I didn't know how long I would talk. And I connected through them. Let's have a look what's running right now. And type the right letters. I did 2 things an hour ago. First of all, I installed our own operator. That's called Boom. Boom, on the other hand, had a look at this GitOps demo repository and that YAML files called Boom YAML. I told him to please install the complete helpers application, I should call it, stack. I want to have logs, I want to have metrics collection, I want to have monitoring, I want to have a reconciler installed, I want to have an API gateway, yada, yada. You get the idea. We just declare the target system's status, and that's what it does. Basically, it installed everything that's within this namespace. So we have a Prometheus, we have a Node Explorers, we have our login, we have Grafana with reasonable dashboards, and we have it all configured. After I did that, it took about 6 to 7 minutes, I configured or took care about ArgoCD, which is the reconciler. Let's have a look. First of all, I needed to tell the reconciler where to look for its configuration, what is the ops repository, where do I find my crap. And on top of that, I ended up declaring an application. This is specific to ArgoCD. I don't want to say which tool is the best tool. It's about the idea. For visualization purpose, I chose ArgoCD for this demonstration. Basically, you tell them, okay, this is your repository you have to check out, and there is a path you should have a look at. And we see it's the overlay dev path. So let's have a look. Oh, there is some Kubernetes stuff. And there is a base description. Let's keep things simple. If I'm too fast, please interrupt me. In the base description, I just told Kubernetes that there is an application that consists of an HTTP, a MySQL, and a Tomcat. I would never use an Apache or a Tomcat within Kubernetes for our software, but just to keep things transparent and visible, I chose to use the classic front-end, back-end database approach. So this is the core, as I said before. It's just a basic description. The Nginx isn't used yet. On top of that, I declared an overlay by the power of customize. And customize as a really cool function, you tell them where its base is. So it knows about the Apache, the Tomcat, as well as the MySQL. On top of that, as we're in the dev environment, it knows the namespace it has to install its application. And it has certain resources in addition, which is the stateful data claim and the namespace, which should be that name. And in addition, the environment will have its own front-end configuration or any configuration. You could use any config map just for demonstration. And there is a patch, and the minimal information that is needed to do a deployment in our world would be to change a version from one to another, and customize will resolve, first of all, the base declaration, will add the overlay declaration, and on top of that will change through patch the image version, and the reconciler will then have a look at this path, fulfill what customize does, and install an application. That's what I did.
Just quickly, I saw that Adam raised his hand. Adam, if you want to unmute, I don't know if the question is related to this specific part, but
no, it's not related to that. I can also ask after the presentation.
I'm fine.
Okay, so my question is related. So there are two things basically that kept me from using GitOps so far. One is how do I cope with failures? So if something goes wrong, how would I fix things by hand to make the reconciler happy again?
Never.
I think that might be even more complicated than a push approach.
No. It's not complicated at all, because if things go wrong, you say that things were right. And the changes you made were here. So you did a commit in your ops repository, and these reflects to the issue. I know I'm at the happy path, green, and really, in the ideal world, I should say, but in general, every change you made is through this repository. So every error that reflects, besides software errors of the reconciler, they happen as well. But if there is something wrong with your application, revert your commit, you should be happy again.
Okay. The other thing is about dependencies. So, for example, we have an application that where you have pretty strong dependency on, for example, installing some specific Kubernetes controllers like Istio, Knative, and so on. So I feel that might be pretty difficult to do in a declarative fashion. Especially, for example, you need to wait until the controller is up to really start, for example, sending something else. Otherwise, you will get, what is it called? This admission hooks and whatever failures, right?
I'm with you. Service meshes are a complete different beast. And I don't know if the pattern of a reconciler saying you have a couple of applications and you want to install a couple of applications, apply for things like a service mesh and Istio in special, because you can do pretty crazy things with Istio. From my point of view, installing Kubernetes itself, I mean, we installed Kubernetes with an operator where we wrote some kind of a abstraction for providers, for Google, for local providers, whatever, and we installed Kubernetes. This is possible, but it took us a couple of months to have an operator that reliable, to have everything functional. And from that point of view, we installed the network CNI as well. I mean, we use Calico, it could be Istio, but if you use Istio, you need to configure it, and as you said, have some kind of a waiting point. So you need to have logic. And every time you need logic on top of just install this place, you need an operator. Therefore, you should be really, you should take care if you want to go that path or not. It's up to you.
But would you recommend it in this case if you need to install really operators or
with the experience of 1.5 to 2 years, where we started with dirty bash scripts and now are capable of installing complete self-scaling Kubernetes clusters within 40 minutes, it's worth the effort, if it's worth the pain for you. The honest answer.
Okay, thanks.
There are responsibilities on both sides. But you need to handle it and you need to take care of it. And what if Google decide to have the new service mesh coming around next year? You need to adapt your operator. Be aware of that.
Okay, replacing one service mesh with another with GitOps, that definitely doesn't sound like fun.
If you design it to have separate services for each of its purposes, one purpose might be service mesh. So you test Istio against Hashicorp Consul, whatever. If you design it like that, to have that separation of concern, you're having a good time. If you're not, yes, you're in hell.
Mm-hmm. Okay, thanks.
Okay.
We do have another question from Etienne. And the question is, and I guess there was another one before around this topic, this is how to implement GitOps without Kubernetes. So if you say in a traditional VMware-based environment.
The simplest approach I can think of is all you need to have is some kind of a SSH key pair. So you, of course, you need to install something to the target box. Let's say you have your operations team delivers you with a virtual machine. So all they shall give you is either a patched VM or a pair of SSH keys. You will log in there and you will install what I describe as an operator. The simplest approach for me would be some kind of Ansible or some kind of Terraform. And you tell Ansible or Terraform to check out a repository where Ansible roles or Terraform manifests are, check it out and apply it to the local machine. And you should tell Ansible, let's keep things simple. The simplest approach, don't judge me on that. A cron job every 5 or any n minutes, just executing the same Ansible role over the same system. And that, you know, with Ansible, you could do anything. From installing an Apache to having a complete complex configuration. All you need to do is have a piece of software, it could be a bash script. All you need to do is have a repository that's reliable, install something that is reliable for you to install whatever you need, and then stop touching the box and communicating through the ops repository. And make your script mechanism, whatever it is, complex in the moment you're the need for the complexity. Does that answer your question?
I have just one comment here. When you are saying you are going to use such Ansible or Terraform, in this case, you are going to use push mechanism, right?
No, I know they're meant to do push, but no one told you that you can't use them to apply their magic to localhost, to just switch their magic. In general, especially if you're using Terraform with a state file that needs to be somewhere. I know that there are habits and or principles within these two logics that are not really GitOps friendly, but I have made really good experience, especially with Ansible, and I would use it.
Okay, thank you.
Can you maybe, hi, this is Flavio. Thanks for the presentation. I have a quick question around, basically this is always a bit the interesting part when you say, okay, you declare, if you have a declarative approach for your infrastructure, but I could argue that as soon as you run your application on that infrastructure, it basically is no longer it basically mutated. It's no longer immutable infrastructure. How does a GitOps pattern maybe help in this kind of scenario? Let's say you have a database deployment and you do it through the GitOps part. Your infrastructure stays the same, but you generate a lot of logs. How does the GitOps pattern help in such a scenario?
In general, I disagree with you. It is immutable. Your data isn't immutable. So your application will change data.
And hence you could say the infrastructure it is running on, the VM.
Your application should not change the infrastructure at all.
But it does, right? It consumes memory, it consumes CPU.
Speaking about compute, okay, I'm with you. In our world, we really just think of, speaking application, the data that changes. So I would take care of the database and would take, of course, my incremental or regular backups, but I would try or use the application bit, the Java virtual machine, the, in our world, Go container, what it is, just logic. So I would always try to separate the logic bit from the stateful data bit to be able to reproduce, better sentence, the other way around. The focus is always to reproduce your application and the complete cluster straight out of the Git. If that does mean to forward logs to a central log store or cloud store, whatever, or to do a S3 backup of your database and tell your application on a new installation routine to draw a dump out of it, then that's the case. Does that answer your question?
Yeah, kind of. I mean, I'm still, my problem is I'm still a bit struggling to see the clear benefit outside, let's say, outside of a Kubernetes cluster. And I have seen GitOps working very nicely, but outside of that world, I still struggle a bit to see the benefit over a push-based approach. Let's say you have your CI/CD pipeline. Why would that be any, or what would be the benefit? Can you explain that?
I'll give you a single one. In traditional CI/CD based deploy pipelines, most people tend to use their pipelines, meaning most of the secrets, most of the configurations will, especially the secrets, is always the pain point. They will be stored within their CD or CI system. If it's GitLab, you know what I'm talking about, or if it's Jenkins, whatever. If you handle that correct, the biggest benefit is that you handle your secrets in an appropriate manner. And you will not have a secret hidden in a pipeline, you will have the secret in a Git repository as well.
No, that is not true. You can integrate secrets management, you can integrate Vault. GitLab supports a Vault integration or a secrets manager from AWS or whatever you use. I don't think that is actually true any longer.
If you handled your secrets already well on your stateful data, it is up to you if you want to push it or pull it by the end of the day. I mean, the pull approach has its charm if you're reproducing more than often, and if you want to rely on a central repository and want to have a target system pulling its information, if you're deploying often. I'm with you in terms of more Kubernetes-like, but I wouldn't say it's only Kubernetes. In that regard, we disagree.
Okay. Yeah.
Regarding the push-pull sort of questioner, I think one thing, at least for myself, that has been quite beneficial to see from a pull model is that there's a central place to manage everything. Versus a push model, if your CI/CD pipelines are pushing changes out, if you want to revert something, where do you step in to undo that work?
Makes sense.
So that's the reason I see the benefit.
Repository as well, because the repository, a commit triggers a pipeline build. Wouldn't it be a revert of the commit that fixes it? That's how, I mean, that's how I would do it.
I mean, by the end of the day, you're switching logic from, if we call it operator, reconciler, however we want to call it, you're switching logic from the target system to your pipeline. That's the deal you're talking about. If that's fine for you, it's fine for me. But by the end of the day, you need to have a description of a piece of software anywhere, and you need to have some kind of logic. If you're fine having it in a pipeline, I'm fine with that. I prefer it having it at a target system.
I think this also speaks a little bit about the separation of operation responsibility. If you have a team that is responsible for managing these services, that use of GitOps makes a lot of sense for that team. Whereas if you are pushing everything to the left, including deployments, maybe it makes more sense to have each individual team to maintain that via a push model. I don't want to debate that, but that is a concern. That is a way of looking at things. And how do you want to maintain, how do you want to manage these systems?
Well, actually, I mean, I don't want to manage any system at all, because that's why I use the cloud, because I actually don't want to manage those. And all I want to do is actually write software. And actually, that is actually a question that I have as well with regards to the separation of those, let's say, declaration. In your model, everything that this kind of, let's say, monitoring related, logging setup related is basically in a ops repository, if I understand that correctly. Whereas where I think this is actually really something that should be part of the developer DevOps kind of responsibility, and hence it should actually be part of the application repository and not necessarily in a ops repository, because then you actually separate it out again, right? DevOps is not about separation. That is a bit, I mean, that's what I...
You're saying that DevOps isn't about separation, but your arguments are about responsibility. In my world, we're a small team and everyone is dev sometime and everyone is ops sometime. And we don't care about responsibilities. We care about errors, test failures, and we fix them.
I have an input regarding the all-in-one repository approach. I mean, we oftentimes deploy several different clusters with the same application on top, and we don't necessarily want to include any configuration in the same repository for that regard. So yeah, it might be a base configuration within the development repository, but the configuration we apply to different stages might differ quite a lot. And so we think of it as one repository represents a system with all it's needed to run the system without the application's code. So that's just our way of thinking of that topic.
I mean, it pretty much depends. If you're saying, or someone says he doesn't really care about infrastructure, that's fine. Everybody's fine to use AWS and or Google and rely on their tools. Therefore, you don't have the need at all to install any monitoring infrastructure. So you have the responsibility at your hyperscaler and you pay them for that. That's fine. Okay, we're, I guess, in the middle of Q&A already.
I guess you stopped basically showing your example. If you want, you can go back and continue the demo. And so we can complete the demo and then we do a full Q&A session at the end.
Okay.
If that's okay.
I'll rush a bit. It's just a click away. Man, most of you who have working with reconcilers will know what this looks like. You have your application that was being declared as a base application, being enriched by an environment, and the reconciler took all the YAMLs and just installs whatever. And if you want to change something, just do a quick deployment, let's say. we want to change 2.4.48 to just 2.4 of our Apache server, and we don't want to mess up the YAML file. And to go or give a side hint to the pipelines. I mean, we have customers where pipelines just change this. The effect by the end of the day is the same. So you have a pipeline mechanism that's changing the dev infrastructure, for instance. So what the reconciler will now do in a minute, or after I click that button, is checking out the system, the Git repository, resolving the dependencies, and hopefully it will find out that I want a new version of my front end. Let's have a look. Let's have a wait. Already done. This is the fancy bit about Kubernetes. You just declare a new version and it handles the rest. Therefore, we had by design some kind of a zero downtime deployment. Same applies for scaling, etc. So this is the new pod with the corrected version, or a whatever version. And I didn't do anything to the target system, nor did I use, besides the get, any command to tell Kubernetes to do something. That's part of the reconciler's job. Basically, that was the last bit I wanted to show. So you have a new deployment. I mean, you could change any piece, any moving target within that declaration. You just have to have something or someone who takes care of it. And all you do for a deployment by the end of the day is a git commit. That's it. Heading over to you, Martin.
Thanks a lot. Do you have some time for questions still?
Of course.
Would that be okay? Good. So any more questions to Christian? Thanks a lot for a great presentation. Huh? It was really much appreciated. Do you have any more questions to Christian?
Just one, Christian, thank you. It's really great to meet you. My question is, what was the mindset for your developer or for your teams when you decided to change from DevOps to GitOps? How your team accept the change from DevOps to GitOps? How did you take the decision to change from DevOps to GitOps? What was the most risky to take? What was the risk to take in this case?
I mean, 2 years ago, GitOps was an idea being introduced by weaveworks. So Florian, who was also on the call, read an article about it. We had a chat and a thought about it. How would it behave? How would it look like? Or we just try it out and change the logic? And I mean, we were a startup, so we were free, happy, and able to try things out. And so we did. The challenges we had was that there were many reconcilers on the market these days, and we tested a lot of them, and we tried a lot of them out. And some of them have advantages in the visual area as Argo. I mean, it looks fancy, speaking honest. Some have advantages in the performance area, like the one from weaveworks. The main challenge for us was to accept that we need to leave the box, leave Kubernetes, leave whatever our compute power is as it is, and just collaborate through a single repository. It took us time to find the mechanisms to make this happen effectively. That was definitely the main challenge. Besides that, we were a pretty DevOpsy team anyway before that, and we didn't change our mindset at all. It just changed the way we deploy things or collaborate or just think deployments at all. Because we started, as an example for our own IAM, we started with Argo. I built a monster of a declaration for migrations of database through deployments, etc. It was really, really, really a monster. And we set a step aside from Argo and decided to use an operator to fulfill all specific needs, because we tried to bend these these reconciler more and more and more to extent that was pretty unhealthy. Therefore, you need to know what you want, which is the right tool for you, and you have to have the people that are willing to join you.
Thank you.
Any more? There's one interesting thought from Edio as well. So he wrote that if you have a reconciler, there are no temptations to tweak something manually, because you know the reconciler will revert your change immediately. So this will increase reproducibility at any time, and it's good for disaster recovery cases.
That is right. I mean, our approach in general is to be able to reproduce a complete system. Either it's Google or on-prem or whatever, including cluster, out of that repository, not just an application, the complete system, as fast as possible.
Cool. Are there any more questions to Christian? This seems not to be the case. So, Christian, thank you very much for sharing your thoughts. It was really a very interesting topic. Thanks a lot for that. As I mentioned before, if you want to see Christian live, if you want to have further discussions with him, there's a good chance to meet him at DevOps Days in Winterthur, 7th and 8th of September. This will be, if you're tired of online meetings, this will be again a physical conference in Winterthur. Get your tickets now. If you don't want to wait until 7th or 8th of September, we do have on the 11th of August, we have another meetup. This time it's about customer-driven contract testing. It's already published on the meetup platform as well. And I will upload the video of today's talk latest by day after tomorrow. So if you want to see something, then check out the video as well. And with that, I wish you all a very nice evening and hope to see you soon. Thanks a lot. See you. Bye.